number 1, figure show two charge Q1 8 microcoulomb and Q2 -6 microcoulomb placed 4 centimeter apart. So this is Q1 and this is Q2, the distance 4 meter. And number 1 is calculate potential at the point A and point B. So point A and the point B, so meaning what is the potential at the point B and the point A. Now for potential equation, potential equation, V is equal to KQ over R, and for the, let's say for the A, at the A here, the potential is come from the Q1 and the Q2. So the Q1 here is a K is constant, Q1 charge is 8 microcoulombs divided by the distance here is a 3, Q1 to 8 point A, and the plus the second V is from the Q2, K, the charge Q2 is negative, so make sure the negative sign must include in the calculation, and the distance from Q2 to A. So this is 4 and this is 3, meaning you can use the triangle here. So this is R is equal to 5. So this is for VA. So now if you calculate the VA is equal to, calculator, 1.32 exponent 4 volt. Same process for the VB, potential at VB is from the Q1 and the Q2. So for the Q1 distance plus Q2 distance. So the K is constant. This is K here is 9 exponent 9, and the Q1 here is equal to this is equal to the Q1 is equal to charge 8, and the distance Q1 to the point B here, this is 4, this is 2, so you can use the Pythagoras here. So this is a square root 4 square plus 2 square, so you can use the calculator to find the value of distance here. And from Q2 to point B is distance is 2 meter, and the Q2 is a -6. So if you use the calculator, VB is equal to -1.09 exponent 4 volt. So this is number A. Continue to number B. Calculate electric potential difference between point A and point B. So from the answer number A, so VA here is equal to 1.32 exponent 4 volt, and the VB is equal to -1.09 exponent 4 volt. So meaning the potential difference between A and B here, or VAB, is equal to VB minus VA, and the VB here is equal to -109 exponent 4 minus VA here is a 1.32 exponent 4. So now VAB is equal to negative, right? 2.41 exponent 4 volt. Okay, continue to number C. Hey, this means the electric field at the point A. So what is the electric field at the point A here? Okay, electric field at the point A. If you look at the Q1 is positive, so meaning if the positive charge for the Q1, electric field produced by the positive charge is outward, right? So this is outward, meaning that A here is E by the charge E1 is direction to downward, and the second charge Q2 is negative. So now the negative direction of the electric field to the center of the charge. So meaning here we have another E from the E2 or charge 2 or E2. This is direction, or you can draw the at the point A here. You have two so at the point A here, so you have E1 direction downward, and you have another E2 here. So now you have the 2E, meaning you must use a resolving vector here. So you must know what is the angle here. So now first you must find the value of the E or E1 and E2 by using the draw the table here. This is for the X, this is for the Y. So for the E1 is on the Y axis, meaning the E1 is equal to 0, and the E1 here, so you must calculate the E or E1 is equal to Q1 Q at the point Q2 over R. Sorry, E is equal to E electric field for E1 is equal to K Q1 over R square, and you can calculate the E2 here. E2 here is equal to K Q2 over R square, and then you can use the K is constant, this is 9 exponent 9. The Q1 charge here is Q1 here is a positive 8. This is a 8 microcoulomb, and the distance here is a 3 centimeter. So this is 3 square. So this is constant. Q2 is a negative, but you don't need to use negative, so you just use the value of 6 microcoulomb, and the distance here for the E2 to the point A here is a 3, 4. You can use the Pythagoras, so this is 5 square. If you calculate for the E1 is equal to 8 exponent 3 Newton per coulomb, and E2 is equal to 2.16 exponent power of 3 Newton per coulomb. This is value of E1 and the E2. So E1 here, because this is on the y-axis, so no need for you to resolve. So this is a 8 exponent 3. For the E2 here, you must resolve to the e to x, and you must resolve to the y, or here is equal to e to y. You can use the triangle here, right? So now if I draw the E at the point A here, so the first is a E1, and the second E is this is E2, and you can use the resolving vector here, so you can find the value of the theta here, right? It's the draw this is a straight line. Here is a E2. So what is the angle here? So the angle here, you can use this is 3, and this is 5, and this is 4, and this is 3. So now you can use the angle here. The angle here is let's say use a tangent. Theta is equal to 3 over 4. So you can find the value of the theta here, right? So the value of the theta, this is E2. So E2 resolved to the x, meaning that E2 is equal to 2.16 exponent 3, and resolve to the y. You can use the I continue. So the E2 here, E2 resolved to the x here is equal to E2 is equal to 2.16 exponent 3. E2 here you can use let's say use theta here is equal to you can use the theta cos theta. So the cos theta here, because this is theta, so cos theta is equal to 4 over 5, right? 4 over 5, right? And the E2 here resolve to the y-axis. So this is, you can use sine, or E2 is equal to 2.16 exponent 3 sine theta. And the sine theta here, sine theta, because this is a theta and this is sine, this is 3 over 5. So sine theta is equal to 3 over 5. So you can calculate the total of the x here is a 2.16 exponent 3, okay, minus time 4 over 5. So this is equal to 1.73 exponent 3. So for the y here, so the plus 8 exponent 3 plus 2.16 exponent 3 over 5. So this is equal to 6.7 exponent 3. Now this is value of the EY, and this is EX. So our next process is so I try here. Okay, so E net or E total or E electric field at the point A here, is equal to square root EX square plus EY square. Now you can use the value of this is EX, 1.73 exponent 3, and this is EY square 6.7 exponent 3. So you can find the value of net or electric field at the point A is equal to 6.92 exponent 3. Electric field unit is a Newton per Coulomb. So this is the answer for the number C.